Hey everyone, it's that Math Magician. On this video, we're going to look at systems of equations and we're going to see how we can use the substitution method. We want to use that when we have two equations, really two lines, and we want to find the point of intersection. And we can do that using the substitution method. So let's jump right into this example problem. I have my two equations right up there. Y equals negative 3x plus 5 and 5x minus 4y equals negative 3. Notice that I already have one equation solved for a variable. My first equation, it tells me that y equals negative 3x plus 5. I know what y equals. It's telling me that the variable y is equal to negative 3x plus 5. And then I have that second equation. That looks a little more complicated, right? It's not solved for a variable. Well, here's where we can use the substitution method to help us solve for that point of intersection. I'm going to take that more complicated equation there, 5x minus 4y equaling negative 3. But notice, I did not write that y variable there because I know what y equals. We figured out in the first equation what y is equal to. Y is equal to negative 3x plus 5. So instead of writing that y variable again, I'm going to write in what the first equation tells us. It tells us that y equals negative 3x plus 5. That is how you use the substitution method. Now we're not done yet, because now that I've substituted that variable of y out for what it really equals, I now need to solve this equation for x. So let's go ahead and do that. I think our first step is to use the distributive property. There is a negative 4 out in front as the coefficient, so we need to distribute negative 4. Well, let's see. Negative 4 times negative 3x, that will be positive 12x. We have negative 4 times positive 5, that will give us negative 20, all equaling negative 3. Let's go ahead and combine our like terms now. We have 5x's plus 12 more x's, that should give us 17x's, still having a negative 20 after it, equaling negative 3. So I've combined my like terms. I think our next move now is to isolate our x variable. I have a minus 20 here on the left side. I want to move that over to the right side. To do that, I will do the opposite of minus 20. I will add 20 to both sides because those 20s on the left side, zero out. I'm just left with 17x equaling, well, let's see, negative 3 plus 20. That's going to give us positive 17, and we're almost done. I have 17 x's. I don't want 17 x's, I want 1x. To get 1x, we'll divide both sides by that coefficient of 17, and guess what happens here? The 17s are going to cancel out to a 1. The 17s on the right side are going to cancel out to a 1. So our x variable ends up equaling 1. So on that point of intersection, the x term is 1. Let's go ahead and write that over here to the side. 1, comma, I still need my y variable. Notice I'm not done yet. Just because I solve for x, I still need to know what that y coordinate point is. And we can figure that out because look at that first equation. Y equals negative 3x plus 5. Remember, that tells us what y equals. So I now know what x is. I can just take that equation, substitute my x term in, which we now know is 1, and we can solve this for y. So let's go ahead and do that. Let's see, negative 3 times 1 will give us negative 3 plus 5. If negatives mess you up, get a calculator. There's no shame with that. Negative 3 plus 5 will give us positive 2. That is the point of intersection 1, 2. That is how you use the substitution method. You only use it when you have an equation where one variable is already isolated. Y equaled negative 3x plus 5. So we substituted that into the other equations y. We solve for x, we solve for y, we have our point. It's that Math Magician, and I'll see you on the next video.